Okay, on three. I want you to say what you got. One, two, three. Oh, I heard a couple different answers there. Let's go over it. Let's go over it. An ad agency gathers information about the habits of Texas consumers who live in very small towns, less than 100 adults. They randomly select 12 of these small towns and then interview everybody. Okay, so they randomly pick which of the small towns and then they interview everybody. That's a cluster. That's a cluster. Okay, a cluster. All right. All right, let's try B. On three. Let's do the same thing. One, two, three. Boom. Systematic, easy. Yeah. That one gives it away every 10th person, right? Systematics. Let me change that color. C. One, two, three. Good. Stratified. Okay. Next one. D. One, two, three. I didn't hear as many simple randoms. So let's see. Miss Hodge is curious about the number of hours that seniors spend writing their college essays. She numbers every senior and gives a random number table to randomly select 50 seniors and gives those seniors a survey to complete. Okay, so let's see what she does. She gives every senior a number and then randomly uses table D or table B or table to pick them. She picks 50 and gives it to them. That's a simple random sample. That's a simple random sample. Okay? That's the definition of a simple random sample. If she broke them into groups beforehand, that would be stratified. But she didn't. She put all the seniors, gave all the seniors a number, picked 50 of them randomly. That's the one she surveyed. Okay, yeah, that's a stratified. All right, letter E on three. One, two, three. I heard like three people. Come on, guys. Here we go. One, two, three. Okay, so I heard a couple different ones. So let's go over E. A business wants to know what its customers think of a new product, and they think that men and women may view the product differently. A random sample of 45 men and 50 women is selected to complete a survey. Broke them into groups, right? Two groups, selected 45 men, selected 50 women. They each complete their own surveys, right? That's stratified. That would be stratified. Right? Letter F. Letter F. On three. Last one. One, two, three. Okay, I heard a couple dissenting voices. So let's see. Podunk School District wishes to give a survey to some of its middle school students regarding the quality of the school lunches served in the cafeteria. From the 15 middle schools in the district, 3 of the schools are randomly selected. The survey is then sent home to all of the students at those 3 selected sites. That one sounds a lot like letter A, right? Where they randomly picked a couple of big groups and then said everybody in those groups gets whatever, the survey, the whatever. That's cluster. Okay, that would be a cluster. All right. Okay, so that was just a little bit of review from last time. That was 4.1 in your book. 4.2 talks about two things: observational studies and experiments. When I say experiments, I don't mean like chemistry experiments where you're mixing things together. That's not what I talk about. An experiment is designed to test something, to answer a question, right? That's why we do experiments. So yeah, it's not necessarily like when you hear the word experiment, you think of like, mixing liquids together to see what chemistry. That's not what we're talking about. We're talking about more about sociological, psychological, medical experiments where we're trying to test something. We have something we want to test and we want to see how it reacts. Okay? So an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. So if I want to do an observational study on somebody, I don't actually give the person anything. I don't give them anything. I don't tell them to do anything. I just observe what they're already doing, right? If I want to do an observational study on people who exercise at least 3 times a week versus people who don't exercise, I'm not going to tell them to go exercise. I'm just going to monitor their I could monitor their health records to see which ones got sick more often, which ones are healthier, right? I didn't tell them to go run. I didn't tell them to not run. They did that on their own. Okay. So that's an observational study, something where you step back and you just watch the results, something that's already happening. Okay. An experiment is where you impose something they weren't going to do. I want you to try this new cereal. I have this brand new cereal that I think is better than the cereal you eat right now. I want you to try it out and tell me what you think. You wouldn't have tried the cereal without me telling you. That's me imposing a treatment on you. Okay? The new cereal would be the treatment. Your old cereal would be what we call control. Okay? That's the difference between the two. That is the difference between the two. So in observational studies, there's no treatment assigned. I don't give you anything. I'm just observing what you're doing. Self-selection, merely observe a characteristic, whatever you're trying to look at. Prospective versus retrospective. Prospective, you pick your subjects and then you follow them. Retrospective, they could have died already. You just look at their medical records, right? Pick subjects and then look up their medical records. If you want to see about people who have diabetes, if you want to see about people who have cancer, heart disease, Alzheimer's, any of these things, you can look up their medical records with their permission or with their family's permission and see what they did in life. What did they do in life? Well, it seems like all of these people who got this disease seem to do this. So maybe there's something there. Okay, that's retrospective. Experimental study, you give a treatment, randomly give it to them. What I mean by randomly is they don't decide if they get the treatment. Okay, observe their response and measure its effect. Okay. When our goal is to understand cause and effect, experiments are the only source of fully convincing data. If you want to be able to say, this causes this causes this, you have to say, you have to use an experiment. You can't use an observational study. Okay? That's the only way to prove this causes this, right? Being out in the sun for a long time causes a great risk of skin cancer. To be able to do that, you have to do an experimental study. You have to do experiments. You can't just observe people. Okay, you can't just observe because that's not enough. You can say, boy, a lot of people who spend a lot of time outside are certainly getting skin cancer. It's happening a lot, but you can't say one causes the other. Okay. One of the big things that you guys hopefully know is smoking. Smoking causes what? Causes cancer, right? That's everyone has heard that. If you don't know that, you should know that. Okay, smoking causes cancer, but they've never, ever, 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 ever that I know of done an experiment on that. Does smoking cause cancer, or does smoking cause a higher risk of cancer? Why not? Why have they never done an experiment? Because yeah, what would be the treatment in that experiment? Smoking. Yeah, giving them, making them smoke, right? That's why an experiment has never been done. It's not ethical to give someone something you think might cause a disease, right? So there's been lots of observational studies done on that, right? Now, does everyone who smokes going to eventually get cancer? No, not everyone. But is there a greater risk, a very high risk, that if you smoke, you'll get cancer eventually? Yeah, there is. We can say that by observational studies, right? Um, so that's the difference between the two. Okay. The distinction between an observational study and experiment is one of the most important things. Okay. It's one of the most important things that we're going to talk about later in the class. So what I want you to do right now is do the example. Okay, read the example, do the example, and we'll talk about it in a few minutes. Okay? Okay, so an educator wants to compare the effectiveness of computer software for teaching biology with that of a textbook presentation. So it's just how you teach the class. It's like E2020. E2020 is a computer software program versus having a textbook, which if you have biology, when you had biology, that's how they taught with the textbook. They're trying to see if the effectiveness is the same or different. Okay. So she gives biology pre-tests to each student in a group of high school juniors, then randomly divides them into two groups. One group uses the computer and the other studies with the textbook. At the end of the year, she tests all of the students again and compares the increase in biology tests scores in the two groups. So I'm not worried about the explanatory and the response right now. What I'm worried about is this an experiment or is this an observational study, and why? Is it something she merely um, is it something she merely observed, or did she impose some sort of treatment on the students that they wouldn't have done before? Yeah, what was the treatment she imposed on them? Yeah, so what treatment did she impose though? Mhm. Not the way that they study. The man I'm looking for the not the test. It's what was she trying to test? What was she trying to test? She was trying to test. Okay, so one would be the control, and one would be the experimental, the explanatory variable. Control is something they've already done. So textbook is what they currently go with. Computer software would be the treatment. Now, these students would have never done the computer software unless she told them to, right? So, because of that, we would say treatment, not treatment, experiment, because treatment is software program. That's the treatment. She's comparing that versus the old method, textbook. Okay. What's the response? There you go. How am I going to, so you know the response by saying, how am I going to compare these two groups? How am I going to compare them? By their performance on the test. So the response is performance on the test, score on the test, whatever you want to say. Do we have to put what? Well, the treatment is the explanatory. That's the explanatory. The treatment is the explanatory. So, yeah, you do have to identify the treatment. Another word for treatment is explanatory. What are you giving these people? If I'm testing a new pill that works better than Tylenol for curing headaches, that pill is the treatment, right? Tylenol would be the control because that's the stuff we've been using, right? If you use Tylenol a lot, that's the control. We're trying to compare to see which one's better. So yeah, so the treatment is the thing you're giving them, which is also the explanatory variable. Response is how you're going to measure. I'll give people a survey and just say, how is your headache now? Out of a scale of 1 to 10, 10 being an extremely bad headache and 1 being no headache, what is your headache after you've taken this pill, after you've taken this pill? Okay? So, okay, so next thing, observational studies of the effect of one variable on another may cause what's called confounding between the explanatory variable and one or more lurking variables. So we got two more new terms. Lurking variable. What is someone that lurks? Someone who is kind of not visible sometimes, but kind of in the back, right? Something that's might be visible, but also might be invisible, but is there, right? There you go. That's what a lurking variable is. Something that you might not see, but is there. Okay, an example of a lurking variable. I told you guys about the observational study about I want to see if people who exercise more live healthier lives. So I get all these people. I look at the medical records for these people who exercised a lot. And then I get a group of 100 of those. And then I get another 100 of people who didn't exercise. And I compare them. Because I want to see if the people who exercise a lot are more healthy than the people who didn't exercise, right? That's what I want to do. What could be a lurking variable? What's that? That would be part of my response, right? That would be part of my response. But what would be a problem? So I'm trying to isolate two things. I want to know if exercising made them live a healthier life. That's what I want to know. So I want to draw as best of a line I can from exercising to living a healthy life. What could be a problem there for me? Okay, so I can ask them. So I can easily ask them, do you exercise 3 or more times, or look at their records for that? Okay, so not necessarily that, but you're getting close. Yeah, health risks they already have, right? Their diet, right? People who exercise are more likely to eat healthier, which is also going to contribute to you living longer, right? So it could have had nothing to do with them exercising, eating healthy. It could have been eating healthy. It could have been family history, right? Family history, there's a lot of diseases where you can't control. You could be the healthiest person alive, but because you have family risks, diabetes is one of them, some cancers are another one, it could happen, right? That's why people say get checked up. There's a lot of forms of cancer who run in families. So, for example, my grandfather died of prostate cancer. So I have to get checked for prostate cancer very early on compared to people who don't have that because it runs in families. It can run in families. So um, there's different things. Those are lurking variables. Okay, you're like, oh, I didn't think of those. I didn't think of those. Those are what we call lurking variables. Okay, confounding. Confounding is when you get a result. These people lived longer than those people. They lived healthier lives than those people. So you're like, okay, well, exercising led to them living healthy lives? I don't know, because there could have been other lurking variables, right? So confounding is kind of like the I don't know. I got my answer, but I don't know if it's true, right? That's what confounding is. Confounding is more of an idea. Lurking variables are things. Okay? Lurking variable is a variable that is not among the explanatory response in a study, but may influence the outcome. Okay? Confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from another. So for example, let me draw a picture. So I want to show exercise regularly. Exercise regularly leads to healthy life. Right? That's what I want to show. But because of those lurking variables, if I get over here, there might be other things that led to it and not just this. This certainly helps. Exercising helps. It's been shown if you exercise more, you'll be healthier, right? but it's not the only thing in the formula, right? There's other things that, like if someone exercises regularly, but they drink alcohol a lot, that's not going to matter. It's not going to matter how much you exercise, right? If you don't eat healthy, it's not going to matter how much you exercise. If you get illnesses that are hereditary, it'll help, but it's not going to be the end thing. It's not going to be, so there's other things here. So when I get here, if I'm kind of like, wait, is it this guy, or this guy that led to the healthy life? If you're not sure what the impetus was, that's confounding. Okay, that's what I want. That's what we say confounding. So how do we get around that? You do an experiment. Experiments, if done correctly, get around those lurking variables and that confounding. Okay, because if you're like, how did I get over here? Was it really this, or was it other things? That's what we call confounding. Lurking variables are these other guys here that might have contributed to this. Okay, so those are the differences between lurking variables and confounding. Okay, all right, so do the example. Do the example. Study by Pamela Hurd at the University of Wisconsin-Madison. All right, so a study done by Pamela Hurd at University of Wisconsin-Madison found a link. So there was a study, and they actually did find a link between high school grades, so the grades you guys are getting now, and your health later on when you're 60. They found a link. They found a line to draw. Okay, analyzing the data from the Wisconsin longitudinal study, which has tracked the lives of thousands of Wisconsin high school graduates from the class of 1957. Hurd found that students with higher grade point averages were more likely to say they were in excellent or very good health in their 60s. That's what they found. That there's no dispute. That's what they found. Okay? But explain how confounding makes it unreasonable to conclude that if you get good grades, your chances of being healthy are better. So why can't we draw a straight line between getting better grades in high school and being healthy? Okay, so what are the confounding? What is the confounding? I'm over here right now. I'm over here. I'm saying I'm healthy. These people are healthy, but why can I not draw a line? Yeah.
Because there's other factors like exercise, diet, DNA, and stuff.
Exactly. Exactly. Just like we were talking about, there's other factors that lead to that. As many as you can. As many as you can. I would always give examples. So just like Ella said, DNA, diet, exercise, all of those, that's plenty. Because that shows that, wait, how did I get to healthy life? Was it because of the GPA or was it because of those other things? If you're kind of like, I don't know, that's confounding. Okay, that's confounding. There's a lot of other things that contribute to it. Okay, so yeah, that would be great if you can say, oh, do well in high school and you'll be healthy as can be at 60. Well, yeah, some people are, but some people aren't. We don't know if GPA created that. It could have been other things. There's a lot of other things that contribute to being healthy, to considering yourself healthy. Okay. Okay, so language of experiments. So we talked about treatment. Treatment is what you give the person. You could give it to a person. Sometimes experiments are done on animals, objects, things. If it's an object, it's called an experimental unit. And what you're trying to measure is called the response. How are we going to know if the pill worked? How are we going to know if the cereal was better? How are we going to know if you really are healthy? How are we going to measure that? However we measure it, it's called the response. Okay? So treatment, we went over treatment. Experimental units are the smallest collection of individuals. It could be people, animals, objects, whatever the experimental units are. Okay? When the units are human beings, they're often called subjects. Okay? Experimental unit, the single individual, person, animal, plant, etc., to which different treatments are assigned to. So whoever you're giving the stuff to, that's experimental unit. Okay? If it's a person, it's subjects. Factor. Factor is the stuff you're giving. The explanatory variable. What is the stuff you're giving? It's a factor. Levels. Specific value for the factor. So if you're giving a new type of pill that will make your headache go away, you can give levels, 100 milligrams, 50 milligrams, 25 milligrams. Those would be considered levels, okay? And then treatment is a specific experimental condition applies to units. So it's made up of factors at different levels, okay? Response variable, what you measure. All right, so I want you, tell me what of each. Answer A, B, A through E for the little prompt here. Okay, so let's try this one out. See how you do, and then there's another one right under it. So if you miss some, you have a chance to redeem yourself. Okay, so a farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizer. Testing out 3 different types of fertilizer. 15 similar plots of land are planted with the same type of seed, but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. So is this an experimental study? Or sorry, observational study or experiment? It's an experiment. It's definitely an experiment. Well, first of all, because you wouldn't be able to answer B, C, D. Or is there 2 Ds? It should be E, F. Yeah, you wouldn't be able to do any of this because observational studies don't have experimental units. They don't have factors. They don't have levels. They might have response variables, but they don't have treatments. Okay? So the units. Who is the stuff being given to? So if once you find out the stuff, let's do the stuff first. Stuff is factor. What is the stuff that they're giving? Types of fertilizer, right? The types of fertilizer. There's 3 types of it, right? Who are they giving that stuff to? The soil, the plots of land, right? The plots, the soil. So in this case, experimental units are actually the ground, okay? Levels. So the factor, does the factor have levels? Yeah, the factor has levels. The factor is the type of fertilizer. There's 3, right? A, B, and C. Level A, B, and C, or 1, 2, and 3, however you want to call it. Response variable. How am I going to know if the stuff works or which stuff is better? What am I going to compare? The yield of the crop. How many treatments? How many different things are being given? Not 15. It's actually just 3. 3 different things are being given. Now there's different combinations of it, but really in the end, it's just 3 things that are being given. Mhm. So levels is once you got factors, sometimes there's not levels. Sometimes there's just 1 level. There's fertilizer, right? The types of fertilizer. Well, what types of fertilizer are there? So if there's a type, this happens a lot when you give like a pill. Like if I give you a pill to take, there's levels of the pill. There's 100 milligrams, there's 50 milligrams, 25 milligrams, so different milligrams. It's just the type, the levels, the different types of factors. That's what it is. But there's 3, right? There's 3 different ones. So I call them A, B, and C. You can say fertilizer 1, fertilizer 2, fertilizer 3, but there are 3 types. So because there's 3 types, those go under levels. Okay. Yeah. Some of the time, yes. I think on the next one they'll have different ones. Yeah. So go to the next one. Last thing we're gonna do. This is the last thing. The example with the test cake pans, testing cake pans. All right, so here we go. Consumer groups want to test cake pans to see which works the best. Bakes evenly. So to work the best, it just bakes evenly. It will test aluminum, glass, and plastic pans in both gas and electric ovens. Okay. So the experimental units. Who or what are the experimental units? The cake batter. Yeah, the cake batter, not the pans, the actual batter. That's what's being done. That's what things are being done to it. So the cake batter. Okay. Factor. Factor or factors? What are the factors here? There we go. The types of pan. The types of pan are one of them, and the ovens, because they're also testing ovens. So yeah, so the type of pans, there's three of them, and type of oven, because there's two of them. That's what they're testing. They're trying to find the right combination, right? Within those, how many levels are there? Don't 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 combine them. So let's talk about pans first. Levels of pans. Three, yeah, three levels of pans. There's three types of pans, right? You have aluminum, you have glass, and you have plastic. And then for ovens, you have two ovens, two types of ovens. Gas and electric. Gas and electric. So you can say five total, but it's not really five because they're not like terms. One of them are pans, and one of them is ovens. So saying five is not incorrect, but a better way to say it was three pans, two ovens. Okay. Response variable. How am I going to know which one is the best? By measuring what? Evenness of the baking. Yeah, evenness of the baking. How it bakes, or evenness of the baking, or whatever you want to say. Evenness, I don't know if that's a word, but I'm going to use it anyway. Evenness of baking. Number of treatments, number of things being done to the batter. There's actually six. Yeah, there's actually six here. But there's different levels of those, though. You're right. There's two main things: plastic, or sorry, pans, and ovens. But within those, there are 6 things. You can do aluminum with electric, aluminum with gas, aluminum with glass, or glass with gas, glass with electric, plastic with gas, plastic with electric. So there's 6 total. Okay.